This lesson we'll be looking at some applications to maximum and minimum problems. We've seen so far how to find the nature of stationary points. This lesson will just be working through a couple of application questions. So let's jump straight into this first one here. A loop of string of length 100 centimeters is to be formed into a rectangle. Find the maximum area of this rectangle. Often with these questions it could be helpful to draw a diagram, and we're going to need to define some of the measurements of our rectangle. So let's draw up a little rectangle. We'll call this x, this y, obviously that'll be x and this will be y as well. We know that the perimeter of the rectangle is 100, so we know that 2x plus 2y equals 100, and therefore x plus y equals 50. If we divide everything by 2 there. Alrighty, we're interested in the area though. The question's asking us to find the maximum area for this rectangle. Now we know that the area we can find by x times y. If I rearrange this here that we found, we can write this with y as the subject, y equals 50 minus x. Now let's sub that y into here, so this will give us x times 50 minus x. So our area will be equal to 50x minus x squared. Now if we want to find the maximum, that implies that it's a stationary point. So we want to take the derivative of the area, so it's dA dx, and solve that equal to 0. So dA dx equals 50 minus 2x. We solve for a stationary point, dA dx equals 0. We'll get 50. We'll have 50 minus 2x equals 0. So x will be equal to 25. Alrighty, in order to determine the nature of this stationary point, so we know it lies at x equals 25, but we want to just show that it is a maximum. There's only one stationary point in this, but let's just confirm that it is a maximum. And we could actually do this through our use of quadratics. We know that a negative x squared will give us a parabola that looks like this, and so it's going to be a maximum. But let's just go ahead and actually show that. So to do that, let's draw up our table. We'll have x, f of x, and the shape. We'll have, when 25, the derivative is equal to 0. So we've got a stationary point there. Let's choose 1, and let's choose 50 for our derivative. So if we sub in 1 into our derivative, we'll get 50 minus 2, which is 48. So that's positive. So we'll get positive. If we sub in 50 into our derivative, we'll get 50 minus 100, which is negative. So it's going to have a decreasing gradient there. So we know that this at x equals 25, it is a maximum, but the question is asking us find the maximum area. So in other words, we need to sub x, no, it's a maximum when x equals 25. Let's sub it into our area, which was x times 50 minus x. Which equals 625, 25 times 25, which equals 625, and we're working with centimeters here. So the maximum area is 625 centimeters squared. Now, as I said before, we actually could have solved this question using our knowledge of quadratics, but I just wanted to show you the process of solving for maximum and minimum points using our knowledge of stationary points. Let's have a look at one more question. This question is asking us to find the maximum and minimum values of this function f of x equals x cubed plus 2. But we've been given a restriction on the domain, so the x values are only from minus 2 through to 1. But the process remains the same. So let's solve the derivative equal to 0. We've got f of x equals x cubed plus 2. F dash x will give us 3x squared. If we solve that equal to 0, we'll get 3x squared equals 0. So in other words, x equals 0. To find the actual coordinate of the stationary point, when x equals 0, we'll have f of 0 equals 0 cubed plus 2. Therefore, we've got a stationary point at 0, 2. Alrighty. Let's determine the nature of this stationary point, because it's going to help to find the maximum and minimum values of this function. It's going to help us if we can picture what it looks like. So let's set up our table. We'll have x, f dash x, and the shape. We've got a point at 0. Let's choose minus 1, and let's choose 1. We know that the value of the derivative at x equals 0 is 0. At x equals minus 1, if we sub that into our derivative here, we're going to get positive 3. So it's positive, so it's increasing there. And if we substitute in x equals 1, again, we're going to get positive 3. So that'll be positive. So you can see here it's a point of inflection. And just to abbreviate that, I'll say POI, point of inflection. It's not a maximum or a minimum. Alrighty, you can see here I've just gone ahead and sketched a Cartesian plane, and I've marked our turning point here, our stationary point at 0, 2, which we just found. If we go back to the question, we're given the restriction on the domain, so x equals minus 2 through to x equals 1. So let's go ahead and find the endpoints of this graph using those x values. So when x equals minus 2, we'll have f of x, just sub that into our original, equals minus 2 cubed plus 2, which equals minus 8 plus 2, which gives us minus 6. So we know we've got an endpoint at minus 2, minus 6. And then the other endpoint was when x equals 1. So we'll get f of x equals 1 cubed plus 2, which equals 3. And just in these little spots here, I'll put in the actual values to make that clear. So f of minus 2 and f of 1. So we've got another endpoint at 1, 3. Alrighty, let's mark them on here. We've got 1, 3 over here. That's an endpoint. And the other endpoint was minus 2 over here down to minus 6 down there. Alrighty, and we know the shape of the graph. We know that it's got a point of inflection here, and leading up to that, that's got an increasing gradient, and afterwards it's also got an increasing gradient. So we can actually go ahead and sketch that. So here's that graph there from x equals minus 2 through to x equals 1. We know at this exact point here, 0, 2, it's got a gradient of 0. It was a stationary point and it was a point of inflection, so it was neither maximum or minimum. But to answer the actual question, which was asking us find the maximum and minimum values of this function, the maximum value we can see is 3, and the minimum value we can see is negative 6. Max value is 3. Min value is 6.